There we go. Okay.
That's nice, isn't it?
So that's how we encode characters. So how do we encode numbers? The way we do it as humans, we take a bunch of characters and we put them next to each other and we got numbers. Right? And you write it on a piece of paper. 1, 0, 3, 6.2. Now that's a number. It's just a bunch of characters next to each other. And we're used to that. We could do that with a computer. We could have a bunch of these characters in strings to make numbers. But again, if you had a number that was 10 digits long, you'd have 10 characters. And it turns out you can do much better. So again, we come up with a way of doing this that uses fewer bits than the obvious way. And we can do much better. We can also make it so that addition, subtraction, multiplication, division are easier to implement in the circuits that we have. And that's a bit beyond what we're going to learn in this course. But it's a reason that numbers are encoded differently than characters. So we've come up with this different way of encoding integers, and it takes 4 bytes or 32 bits
and it's still
to
ones and
encode an
zeros.
integer. It's still all just ones and zeros, because that's all we have, just ones and zeros. And now here's the thing. Since we're representing an integer with 4 of these bytes and a character of 1 of these bytes, somehow when we're using these things, the computer has to know, okay, go get 4 bytes to make an integer. Oh, just go get 1 byte to get a character. And that's why we declare stuff. So we tell the compiler that this is going to be whatever it is, and then it writes all this junk for us that makes it work when we actually write a program. It has to go get all these different amounts of bytes. So it hides that from us, but it makes us tell it by declaring stuff. And similarly with real numbers, which I won't go into, but it's the same idea. We want to represent real numbers with a bunch of ones and zeros. And again, we have to come up with a completely different way of doing it. It's different than characters, different than integers. It ends up using 8 bytes to represent this real number. And again, that's why we have to declare it, because now it's 8 bytes and it's some other format, so it has to know how much to get and what to do with it. So, I don't know if that made any sense. I hope it did. At the very least, it's a different number of bytes for each one. The way they're encoded inside there is different too, but that's perhaps not as important, is that they're different, and that's why you declare them, so that it knows how to deal with it.
In a whole world, so 4 bits always equal a byte?
8 bits is always a byte. Yes. It's just one of those definitions.
Okay.
And it's not B-I-T-E, it's B-Y-T-E, just to make it a little bit different. It's just a bunch of silly names.
Okay. Yep.
And you just get used to it. Okay, so as long as you know what you need when you're writing your program and you declare it, you don't really have to know all this stuff. But this is why you're declaring it. And sometimes that helps motivate actually using the declaration. Okay, so those are the 3 basic types, and pretty much that's all there is when it comes to types in C. There's a few other details, but that's it pretty much. So let's do it. So if you're not already logged in, log in. Start the command line. Make a new directory. Call it day 3. Get into that directory and bring up Emacs on your first program. And don't forget that ampersand at the end of the line when you bring up Emacs. Yeah, you bet. Yeah, you know all this, don't you?
No. I'm honest. What? But I'm gonna go back and repeat the class. I've
Sure,
never tried to
sure.
figure it out class.
You
Yeah,
type in
yeah,
that first name,
definitely.
MK.
Yeah,
And nothing happens.
No,
Yeah.
you gotta do the CPC.
Oh.
I put the link on the
So it doesn't
programming
do
page
anything, you're right.
for
Then
the
you get
site to
into
go
the
to
editor after.
To try it out
So
on.
day 3, then the next one, email
Yeah.
pro1.c.
I put a new link on the programmer page.
Base.
Little last, little last
Then you should get your other screen. Ta-da!
That's okay.
Forgot all
I'll
of it.
show it.
Yeah, so you just say, I'm making a new directory,
5 days.
get it, and here's what I
On the
want to do.
website so far, yes.
You haven't done
Okay. Make.
Make
I
a
haven't given
directory.
it to you, right.
CD, what's CD
But
stand
they're there in case
So
anybody
E, I'm
wants to
just
read
an
ahead.
editor. I'm editing the program,
This is my
making a
work
program,
month.
but what does CD stand for?
Yes, yes,
Something
definitely.
directory.
I understand, which is why I
So
only
make the
require
directory,
just
then
this 1
get the
hour a week.
directory, call up the
But they're there
directory
just
or
in case.
something. So you've named it, now you want to go get it, and here's what I'm going to
Yeah, yeah, exactly.
Emacs program was.
do. Right. E is for edit, that's how I remember that. And edit
Emacs?
means Emacs, yes, the E starts, because Max makes nothing. I mean, I don't care. It's going to mean something to me. Today, I asked about 50 questions last
so
week
you're
that
just-
had to do, this is what I'm doing to remember what it is I'm doing. Yeah, because
Make a
it,
directory.
yeah, so Emacs means I'm in the editing program. This is the
Okay.
editing program, and you're telling the computer now, what do you want to do? Yeah, doesn't that help?
That helps.
Helps
Especially
me.
if we're going to one class. That's
Right, right. Well, so last week it helped, and a week before it helped some because I have 50 questions now. It's things like, why is it like that? Why is it,
Okay.
Yeah.
what if that makes no sense to me? That's like something Greek.
First right.
Right.
So you're you were on there.
Yes.
Okay, so, everybody made it through step 1. Emacs is up. Okay, so you can go ahead and type that in. Remember, prog1.c is just a name. That's not part of the program.
Oh.
Oh yeah, I knew that.
Program starts with the pound sign.
Oh, I didn't know that. Program starts with that.
That's right, I have not explained it yet. The stuff, pound sign include, I haven't explained in main yet.
Oh, okay.
I haven't explained begin and end curly braces. But you have to do them. I really thought.
I'm having trouble with the keyboard more than anything else.
Yeah, there you go. Yeah, definitely don't need the sweater.
Now, do we tab in?
No, you don't have to. That's just for clarity, so you can see it, but you don't have to.
What if you do?
Nothing.
Yeah, you can. No, really? Yeah. Yeah, it's just hard. Okay, so in this one, we are dealing with all 3 of the basic C types. Just to remind you, hopefully,
Is that a
day
W?
2.
Yeah.
Now, I will bet in part it's because it's too hot, and in part it's because of the repeat. Maybe more so that it was too hot.
It's pretty dang hot.
It is, she could do it.
Huh. I'm missing a character.
I know.
And it's 80 in here, she could do it.
There it is.
You should see what a mess this room is every morning. Every Monday morning when I come in here. Food them all the way. Coffee spills.
Do you take care of the room?
Candy and cookies.
No, he probably just does
Random
because.
junk.
He's a good guy.
Oh, it is 8 in here.
Such a mess.
What is that?
Such a mess. They're still kids. Even the guys are supposed to
Yeah.
And my perinding.
Yeah. The brightest and best, they're getting graded out.
Now what?
Yeah, they can pull on that.
Okay, so how we doing?
Was it supposed to do something?
So you've got it typed in. So the next, has everybody got it typed in?
Don't forget to save.
So hit
Hey.
save. Go back to your.
Thanks, Liz.
Thanks, Liz.
Oops. Go back to. All right, I didn't write it down. I should have written it down. All right, so go back to your command line and compile it if you can remember how to compile. If you don't remember to compile, the command is gcc, and give it a space, then dash little o for output file, space, prog1, that would be the name of the output file, space, prog1.c, that's the name of the input file.
Prog.
gcc, space, dash o, space,
Prog1.
prog1, space, prog1.c. That should compile it, and you should get nothing back but another prompt if it works.
I know I did something wrong somewhere, but I had to figure out where it is.
Error, expected blah before A. What line? Line 10.
A equals percentage F.
Where's line 10? It's line 10, 7.
Oh my God, it's perfect.
This is 10.
So
All
there
right.
should be a
You
space
need-
between here.
Needs a comma.
Oh,
There.
see that. Good job. Good job.
Okay, how we doing?
I think I did it.
Undefined reference to print. Okay, it's print F, not
What do you
print.
mean?
That's a print F, not print.
Oh.
How you doing?
See that?
Good, I have to go to the processing and I
Remind
have to-
yourself.
What's that?
Yeah.
So now I have to type a bunch of something
Now you
again.
have to do the GCC, this thing. Just
Yeah.
copy and paste it.
Yeah,
Oh.
keep going, keep going.
Copy.
From there.
Paste.
Remember, it's not a Mac copy.
Oh. Did it copy it?
No,
There you
because
go.
you did all, you had to do control.
Oh. Okay.
There's some, what,
Yeah.
Liz, what was the
GCC.
function where you just do the GCC again and it pops out? rather
Copy.
than
You gotta click, probably.
That's okay, tell me.
GCC, space,
Exclamation
Dash O.
GCC. Type exclamation.
space,
No, but
output
copy
file
paste
name,
thing.
just prog1,
Say
Exclamation.
space, input file name, which is prog1.c.
Why?
I knew there was one, because then it'll come back.
It goes
Every time.
to your history.
It did it,
No,
so it's
doesn't
still.
like it.
Okay,
What
we got
line
a
does
few
it
errors.
like? Can you
So
tell?
take a look.
Yeah.
Alright, get rid of prog1.c.
Okay, look, wait, let's see.
File,
Give
save,
me the
maybe
first
we'll
line.
save it, and that
Oh, that could
cursor
be,
was
oh,
still
you don't have
there.
print F
Not
there,
part of the
the
program.
top one.
That's the
Okay,
top
good
one
enough.
too? Oh,
Yeah.
it's both printed up.
Yeah.
'Cause I already fixed the one.
Try saving it and trying.
And then just do
compiling
this.
it again.
And save.
Okay.
Save.
And compiling it
Not,
again is just
so
that
not
arrow.
me.
There you
So
go.
there's the same thing up there too.
Woohoo! I
Alright.
did.
Well, I know you did, you don't have to do
Slash.
that.
Where's
You
the
can-
save
Oh, it
button?
was right there, but once you saved it, it doesn't need to be saved again, so you're good.
Okay.
Right.
And then do the,
And now, you gotta click, you gotta click,
Damn
then you gotta
it.
save it again.
This is
I know,
so
I
not
don't
me,
like that
Leland.
back
You
and
gotta
forth
click.
either.
then hit up arrow, so you don't have to type it again.
Oh,
There you go.
Oh, that's
that's even quicker.
And it compiles.
Yay!
Okay, and running it. When you run it, you do dot,
Up arrow.
Doc,
dot,
dot,
period, / and then prog1, and hit return.
Is that it?
How we doing?
It says A equals 1.3 and B equals 2.
Yeah, and the value of W is F?
No.
No?
Oh, yes.
Yes.
oh, forward slash, that was up.
Unexpected declaration stated in
So
input
W is
line
that.
10.
You? I know, but if you had to input, it's interesting.
Did you resave? No.
Aha. See, most programmers
We
forget to
use,
save.
like,
That's
that
the
computer.
way- and
Well,
most
this
programmers
is
forget to
computer.
save.
This is writing.
This is telling the computer what to do
How we
when
doing?
we do what we
Yours
do.
is done.
When
Yeah.
we want to make
Done.
When we want it to do something, the programs that
Which is why I
run
do it over and
behind
over
are
again,
built
not-
with this.
So in Excel, there's millions of these. There's so many.
Zillion.
Every
Which tells
application.
you if your cursor's
Like
in
some
this,
people want to start with prog 1 and copy it to
you know,
prog
it's
2
not the
and
formulas behind it, it's
Change it a
literally
little bit.
how Excel behaves.
knock at this
If
stage.
you enter in
When
this,
you get-
do this, you know, I mean, literally, it says,
You can do almost
so everything that
anything
happens
you
in
want.
Excel
I haven't
without
showed
you
you.
telling it what to do is what the program's doing. That's
Yes.
my
Yes, she
understanding.
was doing the explanation, I
Can
thought.
I ask you something?
Yes, go ahead.
So we're still trying to understand and assimilate this
Okay,
into the work
definitely.
that we do, right? So
Right.
is it a fair statement to say that writing a program in terms of Excel, for example, is if I'm typing in Excel and I'm not told Excel what to do at all, everything that happens without me telling it what to do is the program that was written for the computer to decipher what
The background.
Excel means. What
They
is
had to
that?
do all this before they made Excel, right?
So
And-
we can use Excel from the user side, but what's behind it is the programming.
That's right, that's
That.
right.
Okay.
Yes.
So that's just,
Yes.
well, I just want to make
This-
sure of where we are.
Yeah, this
Okay.
is Excel.
This is Excel,
this
or
is
whatever.
This is what you can't see.
Right.
Of
So
any program, of
Of
any
any program,
application,
any
any
program.
application,
Any
Anything you
Correct.
do on the computer has a bunch of this crap behind
and
it.
that's, so it's telling
The
the computer.
command
what
line
to
has a
do.
bunch of this crap behind it. The Emacs editor has this crap behind it. Every single thing you use has this behind it. The operating system, the windowing
all with two
system,
characters, 0 and
Everything.
1.
all with two characters.
That's
One and
pretty
one.
impressive. And then this is the language
Right.
that tells those characters what to do. Right.
That's right, all 0 and 1. Okay,
Well, how
so
do
you
they
got
get
that to work.
Two characters, not just one.
Yeah, why is it that the computer only knows two characters?
It's a good question.
It would be a hell of a lot easier if it had every character on the keyboard.
It would. Basically, there's only 0 and 1 because computer memory is based on the simple concept that electrons. Anybody remember what electrons are?
You've taught us before.
Electrons carry electrical current, generally speaking, in our wires and all this junk, right? And basically what it is it's a very small particle. It's small enough that we don't really know how big it is. It's so small. And it has a charge of -1, whatever the heck that means, right? But what we can do with these electrons and what electrical engineering is all about is actually messing with these electrons. So what we have learned to do is we have learned to make buckets that we can fill with electrons. And we have learned to make drains in these buckets to take the electrons out. And we have learned to control the flow of these electrons. And think of it like water if you want. But basically, we can fill buckets with this stuff. And if the bucket is full, that's a 1. If the bucket is empty, that's a 0. And we came up with 0 and 1 because it's a very simple thing to say whether the bucket has a lot of electrons or doesn't have many at all. So it's simple.
Benny or Amy?
Well,
That's why I think he said that on purpose.
there's a lot of
Many.
there's a lot of mess involved at the lower level. Call it noise, call it whatever you want, but the buckets are never completely empty, the buckets are never completely full. They're somewhere in between. So we have a threshold of how heavy those buckets are. If they're heavy enough, we say it's a 1. If they're light enough, we say it's a 0. And that allows us to make our circuits a little messy and still have them be working correctly. You know, we gave just enough charge to make it be a 1, and we're happy, even if it's not way over the top. So you can think of the threshold is somewhere in the middle. Anywhere above that, it's a 1. Anywhere below that, it's a 0. So it allows us to make things messy. And let's face it, if you can't make it messy, you'll never ever get it to work. So that's the whole idea. You threshold this bucket of electrons to get a 0 or a 1. And they could have come up with a bunch of levels if they were so inclined to have it figure it all out, all these different levels. But they wanted to keep it simple. They wanted something that would actually work. So,
The more complicated
you
if
know,
they want with
the
it.
more complicated it is, tougher it is to get it to work.
Failure.
And with charge, you don't want too many electrons. The more electrons you have, the more likely you are to have them leaking out and making a mess. So we just have a small bucket. We would have a bucket that could contain 95 different
Level.
things, then that would be a really big bucket, and everything would be much more complicated.
Yep.
So, more or less, good enough?
Yeah.
Mm-hmm.
Yeah. So, back to the text of programming. So, in this last program you had, we introduced another control sequence for printf called this %c thing. So, just like with the %f and the %d, wherever that appears in that control string, the corresponding variable gets printed instead. So you can do anything you want with that control string. You have those things get printed wherever the heck you feel like. Finally got to this. Sorry. All right, so let's do another one. This can be prod2.c. And it's somewhat repetitive, but it's hopes of getting you used to all these crazy things like printf. And if you want, you can try to guess what it's going to do before you run it.
Prod 2 or 2?
Whatever you want to call it.
Oh. I did that. I don't like
Yeah,
I did that last
it's
week.
common to forget the ampersand.
I did that last
And when that happens, Control C is your friend. And that's not Apple C or whatever. Control C.
There's no apples on this.
There's a key though.
There's a key
label.
where it was. Yeah.
I don't like it.
Yes, you do.
No.
You don't have to like it. Do it.
It smells.
And anything new, the startup transients are somewhat
We're
painful.
talking to an accountant who needs to know what every period.
See, now I got a whole new thing, and I don't think that's right.
what you need. Yes.
That's exactly what you want to do. You want to start fresh with another Emacs, type this into a blank file, and save it. It's prod2.c. Because you're getting used to typing. Pound
Is it
sign,
necessary
include.
to put the spaces between the equals? No.
No. There's a lot of places where I'll put spaces just because it's easier to read.
Okay.
And whatever you want, pretty much. Like between the printf and the first parentheses, you can put as many spaces as you feel like. Doesn't matter. Around these semicolons and commas, you can put all kinds of space if you want. And around the equal sign, you can put space. Even around the curly braces, you can put space.
Wow.
Yeah, it's ridiculous.
Yeah.
It's dating here.
I think I already did that.
Hey.
So anybody have any guesses as to what this will do when you run it? So one thing we're doing here that you've probably never done before is we're actually printing without ending it with a \n like we almost always do, which is perfectly valid.
Why is this one in red?
Keep going, it goes away.
The editor you're using is attempting to colorize the text based on what it thinks it means. And eventually that helps out.
Oh my God.
Oops. I hate this keyboard.
Yes, it's true. Different keyboards can drive you crazy. I definitely understand that.
I don't even know where I'm at.
How are you doing?
It's all too much. Same.
And you got next. Exactly. It's printed an N, and then an E, and then an X, and then a T, and then a new line. Doing good.
Oh, shit. Oh, no. I don't even know where I'm at.
Getting there, getting there.
Right. That's my understanding.
Yes, definitely. Definitely.
And then save. Do we have to hit save?
Yeah.
You always have to save it, otherwise whatever the heck you did isn't saved.
Now
Nobody
what do
will
we
save
do?
But you.
Now what do we do?
Now you
Okay.
do the
Now you compile it,
GCC.
the GCC stuff.
Right
So,
here?
go ahead, go over here, click, type GCC space -O, output file in this case is prog2, so another space, prog2, space, prog2.c. Alright, close. Line 11. You've got a period, and you need a comma. Remember to hit save. See, this right here is saved, by the way. See that thing? That's saved.
Comma. Why can't I get rid of that?
Here, let me help.
See, it has to be on the thing. It looks like I would take the
Yeah.
there's the backward.
Backspace gets rid of the thing in before, yeah.
And I do something else again now.
So you just do it again.
Did you hit save though?
Yes.
Just do it again.
And no, that was the up arrow.
Yep, up arrow, and it worked. All right, so now type in /prog2 to run it.
Oops.
And type next. You got it. //
3.
Yep.
And frog would have.
prog2.
3. I named one 3.
Named it 3. Yeah, okay. Next. All right. So how are we doing, Poonam? Does it work?
It's
Almost.
quarter to.
Okie doke.
Way over my.
Now,
I can't. I don't like it. I don't like it.
it's confusing.
My
I
brain's
cannot
not
imagine
metaphor.
sitting at a computer and doing this. Oh my God.
Yeah. You just be patient.
How much?
It really helps me understand. I spent 15 years programming for the helps me kind of understand.
Yeah,
They
I mean,
lack
They're a
the
little
social
different.
skills.
I'll admit, programmers spend a significant amount of every day dealing with the compiler, dealing with all the annoyances that come from the compiler. And so they get used to interacting with a compiler. So interacting with people is a little bit different.
Helps me understand. Man, that is hot.
This room is hot.
Wow. Shouldn't be that hot, right?
Ah, seems too hot.
Just yours?
So how we doing, Poonam? Got that working yet?
Mine's warmer than that.
Almost.
Next.
Okay, so yeah, next.
No, I meant that's what it said.
There's one special feature about characters that's really kind of strange, but it has a good reason. You can also treat it like an integer sometimes. So here's prog 3. Why don't you try that and see what happens? See, we're doing something strange. We are adding 1 to a character right here.
Okay.
So, see what happens when we do that.
Okay, I have to call my something.
Go ahead, call it prog 4, whatever you want.
Okay.
So, isn't that me? I can't remember any of these things.
Emacs.
This buffer is for notes you don't want to save and for list evaluation. If you want to create a file, visit that file and see. Send it to the tag.
Start typing.
What does it mean, start typing?
Okay, you compiled prog 1 again. You need to compile prog 2 and split it into a file named prog 2. So, if you do that, then you don't need the image. That should compile it.
Okay.
And then /prog 2 should run it. Good. Okay,
See,
now
this
there's this
is
next one.
I shouldn't be doing that in there.
It's fine. Everything before the pound sign you're just going to copy, or you're just going to select and then delete. It's easy enough. Watch.
I don't know what it...
Just select it, and we'll hit delete. And don't forget the curly brace. End curly brace. Usually what I do is end curly brace. And now I start typing inside.
Oh.
That way I don't have to remember to do the end curly brace.
Okay.
Okay. Oh, well, helpful.
So if this all seems too strange and something that you think you'll never ever get used to, give it a chance. You'll never get used to anything new unless you give it a chance. And I realize giving it a chance means that there's some reason to give it a chance. But we really can do useful stuff with this. Trust me. We talked about it, right, Jean? We talked about it. We can do some of those things that you do
Yeah.
manually. We can write a program to do that.
You assured me we can't.
And then,
Or that
you
you
know,
can.
you run that instead of looking through it with your eyes for half an hour to
Right.
an hour.
That would figure out.
And then,
Why won't it let
you
me
know you didn't
save?
miss anything, and 2, it's quick and you didn't kill your eyes doing it. So, now,
It won't let me save.
you need to do save as, because you brought it up in a strange way. So, give it a name,
Prog 3.
prog3.c, and hit OK.
Now,
Now you can try to compile and etc. Go back to this guy. And, okay, we did Emacs without an and, so
see, I don't know.
we'll quit. So now let's try to compile. It's prog3. So let's name the output file prog3. Woo! And then we run it. Prog3. And
Told you to come back.
it's not quite there yet,
You don't want to do
inch by inch.
it.
So
You really don't
let's,
want to.
let's do Emacs prog3 dot C and what did we do wrong? Printf, sent C.
Number include. I didn't write prog3 at the top.
W equals
Oh.
save, compile, run, N-O. Yes,
Is that right?
success.
Okay.
So, what did it do? What did adding 1 do when we added 1 to that character?
I don't know.
It went to the next letter in the alphabet. So, the letters are arranged alphabetically.
How did?
What's
Oh,
correct?
because W equals
So then
1
you can roll
N.
the math.
Oh,
And W
L N
plus
O.
So we can alphabetize by using numbers instead of letters.
Yeah, and how you compile and do all that. I have to go back to the first one.
Right,
Already
so
there.
yeah, it is,
I've
it's
gotta
the
have some
sequencing
notes.
of when to do things.
Right.
So that's the idea. The letters
You know what I mean?
are in the same order
And that's
as
the
the integers.
Yeah.
That way we can alphabetize, and alphabetizing is a big deal when it comes to computers, right? You get a random list of student names, wham, you can alphabetize it and spew it out. So that's a key thing you do with computers that is, makes it, yes, no and again, just Control C. Now try. Okay, so exercises, yeah, with what time, right? When you get around to it, you could perhaps do exercises in your free time.
Still 7 minutes?
We do? We have 7 minutes?
Yeah.
Woohoo! Okay, so who wants to, you could do one or both of these as you wish, right? You actually have 7 minutes. Cool.
How that Liz ever helpful.
Just think of it like a workout.
Yeah, well, I don't like doing that either.
It's a little too hot in here to concentrate, I gotta say.
Okay.
Makes it difficult. Hang in there.
I don't have a clue what to do, so. Do I get a new thing? I don't know.
So, it's the standard programming.
Why couldn't I mess up this one? Why couldn't I add to it?
You could, but we're trying to get you used to doing everything over and over again so that you remember. So we're having you start from scratch every time.
That's the Emacs thing?
It is. Yeah, Emacs. So every time you want to edit something, you type Emacs, space, file name, and then an and make sure that that command still runs and your command line is still running. Normally your command line will wait for every command you run to finish before it lets you do anything else. That's what the and is for.
Okay. And I didn't name it program anything. I named it name, because that's what you wanted to do, name the character.
Yeah, call it whatever you want. We will start naming things a little bit differently soon.
So,
Because you can name it anything you feel like.
Well, let's see, my name has changed, but I got it. Oh, yeah.
You didn't print F %C, you
Gotcha.
just printed F \n.
Gotcha.
I know my face is like on there.
Yeah, I feel like I'm burning up.
You get it?
I didn't.
Your name?
With a capital L.
I messed with them.
How did I do it? I just went back to the big one and I cut the change.
But see, mine went away when I got a new one. Oh, I see behind it.
That's right.
Behind it, that's right.
Oh, I can copy and paste.
They can be on top of each other.
Okay, all right, that's cool. So main and that, okay, and then we go character. Whoop.
So it turns out that every key on the keyboard is a character in this thing. So that's why \n is actually a single character in C. And that's why we can print it, because it's one of the characters on your keyboard. And it's represented in the character data type. And similarly with a bunch of other crazy characters. Control C. Up arrow, down arrow. So those are all characters.
Oh, that's fine.
If I was to do that, number two,
Uh-huh.
would there not step be under W plus one?
Percent, character, and comma W, that.
Well,
And
try it
then
and see.
equals
What? That's not what I'm supposed to get.
A,
Oh.
with L.
Well, there's one character you're missing.
And
This thing.
W equals N.
Well, look at your previous program. What was the last thing we printed?
Uh-oh. You know what, I don't have
No, no,
those on the back of
In
everything.
the code. The last printf that we had in the
Alright, now what do I do, Karen? Alright, now what? I go with my ampersand, my amper little thingy.
Yeah, finish up your closing.
Well, it's not in the right spot.
Yeah, it doesn't matter, I don't think.
Without that,
So make it and then
it
hit
doesn't
save.
give you an enter.
And what's the name of your file? Is it
So
Frog2?
you
Name.
just print,
I
Huh?
think it's name.
Okay, so just save.
so it's kind of,
I don't even know what it's named.
Yeah.
That's not gonna help
So
me,
you'll
is
be
it?
able to find out in when you go to your
Oh,
terminal.
name that thing, right
There you
there.
go.
Don't know what.
So now you gotta go back to your terminal, to your compiler there.
yeah.
And
Well,
no,
look at
no,
it.
no,
If you
that's
want,
the minus,
if
it's
you want,
GCC minus
I
O
mean, you can,
space pro, and then name your file,
C.
and then name,
oh, complicated stuff that you might want to,
maybe it's just name and then name C. But because there's two where you have a GCC, because it's the name of it, then point C. So it's name and name point
and
C,
that is
point C.
another standard
And then
thing that
return.
we do when we program.
Oh, I got them all. Oh, well, I tried.
logged out or something.
I'm getting out. I'm good. I'm done. Oh, yeah, it went well. How do we get out of here?
You just do, go down to the,
I don't know. Just say
system,
I don't
up
know
on top, log out.
minus O,
Yeah, you forward on C.C.
and then cross
Yeah, that's all.
two.
Okay, think we can slip out before he marks.
I don't, I mean, I think I'm not, but I think we should.
Backslash N.
Thank you, Leila.
You bet.
Thanks.
Perseverance.
Another wet room.
Yeah, this room got flooded.
So control,
We had the,
From upstairs?
yeah,
next
from
is
that
control.
third floor flood, yeah. So we actually had to turn off the dryers.
I'm going in the right direction, just saying, I have ADHD.
Yeah, and if you keep going,
I get
it'll work.
ADHD. That's what it
Yeah, so you just keep adding on. Because the previous one
I
got.
got it, yeah. It kept doing that when you said it. I'm like, and
And you, here, take this up too. No, here, take it up.
Starting
No, put it
writing
in.
down.
You make a little note.
Yeah.
Good.
Control C
Control C.
And of course, there's homework.
Thanks, you too.
Yeah, that's the list.
Thanks, Leila.
And the other,
You bet.
and a lot of the other stuff you're learning is about the compiler.
How we
which is
doing?
GCC.
Okay,
Okay, just so you know the difference.
okay. Hey, we get so cool off.
Yeah, terrible. Yeah. Paul's not here. She's in the class, believe it or not.
Oh.
But she has yet to attend.
Oh.
I saw her just before. She was running around doing something. Yeah.
Okay, I got it mine too.
You bet. You bet. Well, there were only 4 of us, so. But yeah, repeating is key.
It is.
All right. I've been doing this for 35 years, and I'm constantly typing in the same stuff over and over again to do what I need to do. And it just becomes like second nature. If you want to do something, you got to type.
And I haven't done this in, 25 years, and I can't remember anything.
It's definitely a use it or lose it kind of thing.
It is. It's a lot of space and space. And I know you guys want to make like an Excel how it's good, but if you don't need a space, it's don't put it.
It doesn't matter. It doesn't matter. Yeah.
Okay, but.
As a matter of fact, the semicolon, the reason for the semicolon is to tell C, this is the end of this executable statement. So you could have the whole program be one line, okay? Because it doesn't need
Right,
character. We do.
Right, because
It
it's
could
your,
care less.
yeah, you need to
Doesn't need
understand.
spacing, it
that.
doesn't need character turns, it doesn't need any of that crap. Yeah.
Okay, bye-bye.